Dear students, myself Dr. Adesh Pandey. I am teaching application of soft computing in 7th semester. So today we'll formally start our first lecture, Introduction to Soft Computing. As we have discussed in previous semester also, and I have communicated to you and in classroom also when I was teaching you theory of automata and formal languages, it is very important for teacher and as well as for the students also to discuss about the subject before starting the subject formally. In other words, we have to do the context setting of the subject. So as a student, you have to understand why you are going through this subject. What is the application of this subject? As a teacher, this is also my duty to communicate to you how important is this subject, what will be the flow of the subject, and what kind of topics will be covered, what is the history of the subject, and once you learn this subject, what is the learning outcome expected out of this subject, where this subject will be applicable when you will work professionally in different industries, and moreover, you will connect with the subject only when you are clear about the industrial application of the subject. So in today's lecture, we will discuss, rather than I will not use the word teach, we will discuss about the soft computing paradigm, how the soft computing is different from the classical methodology of computing, which we are doing on our computers or on machines, different machines. So today we will do the context setting of the subject. So I'll request all of you to kindly note it down there, your doubts. After this class, we will discuss your doubts and other thing which you are coming in your mind about the subject. So let me start formally the context setting of the subject. So let me discuss with you all. Did you ever feel that some kind of when you are taking some decision, some imprecision in there in your mind about the decision, you are not clear about the input. So once you are not clear about the input, even your input which you are trying to give to solve the particular problem is not perfect, not complete, having a lot of noise up there. I think you have gone through the data mining also. So you understand the meaning of noise. So in that particular case, when data is not complete, data is not pure, noise is there, data is imprecise, lot of you assume that lot of imprecision is there. In that situation, how you will try to solve the problem? See, as a human being, our mind is trained. See, when we compare to the computer to our human brain, you understand that whatever algorithms you are writing while solving different problems on your classical computers which you are using right now. So you are clear about the input. Your input is complete. Your input is complete, your input is precise. That's why once your goal is to write a perfect algorithm and you are clear about the input, and you will get a crisp output. When I say crisp output, complete output. There will be no boginess at all. So either it will say yes, the problem is solved completely, or problem is not solved completely. Have you ever thought about something is in between the true and false? In computers binary language, we can say true is 1, false is 0. So let this subject give you a lot of insight. What is there in between? Is there any possibility to be something be there in between 0 and 1? Can we say that? But in day-to-day life, we were quite comfortable about the between 0 and 1. Let me take the one example. We usually say I am very pakka friend of, I am very fast friend of that particular fellow, but I am the friend of fellow Y also. To whom I am the fast friend. So I can say I am a friend of X and I am friend of Y also. So to deal with this kind of a situation between 0 and 1, we have to use the subject of soft computing. And first of all, we have to understand the meaning of soft computing. So in today's lecture, we will try to do the context setting of the subject, try to understand the meaning of soft computing, how it is differ from the hard computing, and what are the different paradigms of soft computing, what is the historical aspect of soft computing, how different researchers have coined the word of soft computing. So I think after today's lecture, you will be able to connect with yourself to the subject. That's very, very important when we are starting a new subject, especially in first couple of lectures. So next 2-3 lectures, we'll try to discuss about the soft computing, its paradigm, its history, its application in industry as well in day-to-day life, so that we as a teacher, as a student, we all can connect with the subject. Then my dear students, learning becomes very easy once we are connected with the subject. So let us start formally. So this is our today's agenda. Introduction to soft and hard computing. As we were discussing that, so we will differentiate between the soft and hard computing. Then what are the different branches of the soft computing and application of the soft computing. If time permit, we will discuss in today's lecture itself application of soft computing. Otherwise, in the next video lecture, we will discuss the application of soft computing. So let me ask a question. What is soft computing? What do you understand by the soft computing? This is very, very interesting. Computing, we all do. You study a lot of algorithms, a lot of programs you have already written in first year, second year, in third year also, in different programming language. C, you did a lot of labs of data structure algorithms, either in C, Java or Python. So you already learned computing. So how the word soft, when we add the word soft in computing, so how it makes different than the computing which you are doing till now. So that is very interesting to understand how the soft computing makes different type of computing, how the computing becomes different when we apply the soft computing approach. So this will be very interesting to discuss. All right students. So let us discuss about the soft computing. See, when we talk about the traditional computing methodologies, as I was discussing a little bit earlier, you are very clear about the input. Your algorithm is very clear. Your information is precise. There is no noises at all. And you are very clear about the output also. If your algorithm is correct, your steps of the algorithm is correct, then output will be correct, true. Either if your algorithm is not correct, then output will be false. But there will be no approximation of the solution. It will not happen you are very near to solution and you are not getting a precise solution, or you almost got the solution, or you will get the solution after some more iteration or applying one more time one more step of the algorithm. This kind of a thought process will not be in classical computing. But the soft computing provide you the opportunity about the approximate models, approximate solutions. So unlike soft computing, hard computing is there is no imprecision, there is no partial truth, there is no approximation at all. But this kind of facility, this kind of a phrasing is allowed in soft computing. The algorithm or model which is we called is soft computing. So tolerant of imprecision is there. It can handle a lot of uncertainty, partial truth when you are not having a complete data, and it can give you approximation also. When I say approximation, it means in most of the times when you are applying the soft computing models for solving a particular problem, then probably you will be little bit around, just around to the solution. Probably you will not get the exact solution, but you will be very near to the solution. So you, as a student, you must have this query. What is the fun to apply the soft computing when we are not having a perfect solution? My dear students, in day-to-day life, there are some real problems which we cannot solve by applying the classical computing methodologies. So in those problems, first of all, it is very, very important task to identify the problem on which we can apply the soft computing. Otherwise, if you are not clear that if the particular problem can be solved by applying the classical algorithms, then we are wasting our time. So it is very important to understand which kind of problems are fit to apply or fit to be solved by applying the soft computing methodologies. Let me again clear you the meaning of soft computing. The role model of soft computing is human mind. So here we are trying to develop the algorithm by applying the soft computing methods so that the computer becomes or computers are able to solve the way human thinks about solving a particular problem. So soft computing is based on the techniques such as fuzzy systems, genetic algorithms, artificial neural networks, machine learning, and expert system. And I think you are you will be aware about this. These are the buzzwords now. A lot of research are going on artificial neural network, machine learning, AI, expert system, deep neural network. So this is, if I say this, soft computing is a superset of all these terminologies. And I'll discuss some of the method applications right now also, so that you become comfortable about the soft computing. It is used to successfully in many domestic, commercial, industrial applications. Let me give you a very small example to understand the application of soft computing. I think in all our household, we have washing machines. Now since last couple of years, the washing machines of all the companies which are famous in the market are coming with the fuzzy controllers. It means the machines are intelligent enough. Machines are intelligent enough to understand, to judge about the quality of cloth. Let's say woolen. Then the next question, how much woolen? Let's say the kind of a particular your mom says that, or when you are handling with the cloth manually. So this is a cotton trouser, cotton shirt. So we have to deal with a little bit delicately, and how much soap has to be applied. Manually, when we discuss this kind of things, this kind of a question arises when we are handling our cloths. But nowadays, the washing machines are fully capable to do these kind of things, or they are able to think intelligently how to handle different kind of a cloth. So how this happens? Because these washing machines are having a fuzzy controllers. So they are able to think between the 0 and 1. How much? Not 100% cotton, not 100% woolen. If the cloth is having a, let's say 60% woolen or 30% cotton, then also the washing machines are able to adjust accordingly. So this is one of the example which I thought let us discuss right now also, so that you become very clear about this application of soft computing. All right. Then if the soft computing methods can help you to understand having a lot of imprecision, lot of untruth, lot of incomplete, lot of imprecision of the data, then what is hard computing? See, whatever algorithms you have studied in data structure, algorithms, or anywhere while you are a mechanical student or electrical students, so you are writing different algorithms. So conventional mathematical models, when you are writing algorithms by using the conventional mathematical methodologies, then those kind of algorithms are called the algorithms having a hard computing models. But what are the limitations for the hard computing models? They need exact data output. Use a precise methodology. They are not able to deal between 0 and 1. They deal either with 0 or 1 and generate a precise output, which makes it a crisp system. When I say the crisp system, it understands either 0 or 1. It does not understand between the 0 and 1. So it fails when the input is not exact. So you write a wonderful algorithm, but if you are not clear about the input, your input is not exact, then you cannot expect the output which you want exactly. The example of conventional algorithms are many, but here I have mentioned whatever algorithms you studied as a computer science or IT students: merge sort, quick sort, binary search, greedy algorithm, dynamic programming, etc., etc. Lot of algorithms you have studied which are deterministic in nature. All those algorithms are example of soft computing, right? I hope I make the point very clear. So this is how we can understand the difference between the soft computing and hard computing. Let me summarize again. The algorithms which are written by applying the methodology of the soft computing or soft computing models, they are able to handle a lot of, if data is not exact, not precise, or having a lot of dubious in nature, a lot of boginesses are involved in data, then also the algorithms which are written by applying the methods of soft computing are able to deal with those kind of data. But in classical mathematical methodology or hard computing, The data should be exact, precise, and there should not be any ambiguity in the data. There should not be any boginess in the data. Otherwise, in spite of writing a good algorithm, you cannot expect a good solution. All right, dear students, let us move forward. So it is also important to understand historical aspect. Who was the first researcher to coin this word and how they observed the word soft computing? And what kind of research in today's time is going on, that is also very important to understand. So if we see the era of 90s, 1995, 1950 around, so a lot of traditional or classical algorithm has been written to solve the very critical problems successfully. And all those algorithms were valued based on the logic and classical mathematics. However, if we see this kind of some scientist, a mathematician, especially Jade, he was a founder of the fuzzy logic or fuzzy set theory. So Jade has observed that if we can write some algorithms which can handle the situation between 0 and 1. So when data is imperfect, imprecise, a lot of bogginess involved, and we expect output in between 0 and 1, then what will happen? So this kind of a thought process was going on in his mind. So what he proposed. So he thinks something about the intelligent computing. And somewhere around in 1995, John McCarthy was the first scientist who organized a research project to do more research. So AI became a field of research to build models and systems that act intelligently without human intervention. My dear students, this is a very powerful sentence when we say that without human intervention. So let us understand the meaning of this sentence, how the technology or algorithms which are based on models of soft computing can help us to develop the machines or the softwares which can act without any human intervention. So amazing a situation, just you are in remote location of India or in a remote particular remote village where doctor is not available and somebody is critically ill. So what will we first we will do that? We will try to find out some mode of transportation and we will try to rush toward the hospital. But let us assume that there is not much time available and we want to give some first aid or some kind of a medicine to the patient and doctor is not available. Imagine there is a computer system which can behave like a doctor. When I say which can behave like a doctor, it means it can simulate a doctor. It will pretend like doctor is available. If doctor has been there and the patient is ill, how on the basis of symptoms the patient carries, how the doctor react. So that is the goal of making a computer system. We call it expert system or knowledge based system, so that the system can respond as the human intervention is there. But actually human intervention is not there. The system based on the soft computing is behaving intelligently. So in mid-80s, Jade focused on building a systems or making a computer which can think like a human beings. So he the first time proposed the algorithms based on the soft computings which can develop a computer based softwares who can think like a human being, or in larger sense we can say that we are somewhat able to simulate a human behavior, human mind. So for the purpose, the machine's ability to compute with the number, which is named as hard computing, has been supplemented by an additional ability more similar to human thinking, which is named as soft computing. Let me make this point very clear again. So that the traditional methods of writing algorithms, where we are using logic or classical mathematical based logic, has been supplemented by the ability of algorithm, in which algorithm can take decisions, can think intelligently and compute intelligently and take some decision on the basis of environment or systems or their learning. So that kind of algorithms or methodology is called soft computing. I hope the point is clear now, the difference between hard and soft computing with this application. So let us move forward. So historical aspect we were discussing, the idea of soft computing was evolved in 1981 when Jade first time published his paper Soft Data Analysis. In Soft Data Analysis paper, he explained with detail how the soft computing models can be applied and used in algorithms to develop the intelligent computing systems. So once he, in this particular paper, he presented that how the soft computing methods can handle the imprecise data, incomplete data, and the boginess involved in the data. And the main branches of soft computing are three, which are there in your syllabus also. The fuzzy system, evolutionary computation, and artificial neural computing. Your first 2 units of your syllabus is based on artificial neural computing, and next 2 units are based on fuzzy system, and the last unit is based on evolutionary computing. So I hope I did a proper context setting and you have understood the meaning of soft computing and the importance, industrial application of soft computing also. So let us rephrasing the sentence as per the Jade. Soft computing, according to Professor Jade, is an emerging approach to computing which parallels the remarkable ability of the human mind to reason and learn in an environment of uncertainty and imprecision. So as I previously, in the previous slides, we were discussing about when data is having a lot of uncertainty, a lot of boginess, a lot of imprecision is involved, then also this kind of algorithms are able to compute and give you the approximate solution. See, approximation solution, there is not always good to think about the approximate solution. But if we encountered with a problem which are really difficult to handle with the classical methodologies, then in spite of not having the solution, it is better to have an approximate solution so that we can lead further. All right. Okay, so I think this picture will give you the more clarity about the branches of soft computing. As we were discussing, there are 3 branches: fuzzy system, evolutionary computing, artificial neural computing. So see the third one, artificial neural computing, have almost all the current research on AI is going on this area: machine learning, probabilistic reasoning, belief network, or parts of learning theory, wisdom-based expert system, and a lot of other things also. So we can say that soft computing is a superset of all these 3 things. Fuzzy system is a different branch. It's a branch of mathematics rather. We will discuss a little bit introduction today also. And evolutionary computing, I think, based on genetics, which you have studied. I hope you study something about the genetics when you were studying the biology in 10th class. Artificial neural network. This is basic summation models. Where we can design a artificial neural network which can simulate a human brain. This is what we are going to, all 3 things we are going to learn in our soft computing syllabus. As I told you, first 2 units belongs to ANN, artificial neural network. The next 2 units, 3rd and 4th, fuzzy systems, and the last unit, 5th one, is evolutionary computing. All right, guys. So what is fuzzy system? As I told you in this lecture, we'll try to have a clear picture of soft computing syllabus so that when you go in a particular topic in detail, you have a fair idea what is this topic and what is the industrial application of this topic, right? All right, guys. So as I was discussing, most of the times when we deal with the probabilistic nature of the problem and imprecision is involved, when we apply the classical mathematical model, classical algorithm to solve, or hard computing, now we are aware about hard computing to solve the problems, then we expect the output either true or false, or 0 and 1. The fuzzy system is a branch of mathematics which allows us to deal between 0 and 1. So there is a life between, this fuzzy system tells us there is a life between 0 and 1 also. So either, for example, let's say I was giving the friendship example. So if your friends ask, so today we'll go for the walk, you'll say, it may be or may not be. You see this sentence, the power of this sentence, it may be or may not be. What are the chances that you are going to on a walk with your friend? Let's say 80% probability is there. Then 20% probability is that you are not going with your friend on a walk, right? So fuzzy system give you liberty to deal with this kind of a imprecise or ambiguity involved in your sentence. So if we see, we are all aware about the set theory. In set theory, let's say there is a set A which have a 10 members. Then degree of all those 10 members either belongs to set A or does not belongs to. Let's say set A has members 1, 2, 3, 4, 5. Then all these 5 numbers 1, 2, 3, 4, 5 belongs to set A, and all other numbers other than these 5 numbers does not belongs to A, set A. This is the classical set theory. Now just imagine that you are dealing with a situation, you are defining a new set theory in which the definition is set is little bit different. How it is different? Let's say you say there are 5 members in set. The first member is member of set A with the probability 60%. This probability of 60% is called degree of membership. How much percentage, how much chances are there this particular object or element belongs to set A. Then the next element with the 40% and that's and third element and fourth element and fifth element. So every element has its own degree of membership to a particular set. This degree of membership nothing but the probability which the member or object belongs to a set. And the range is between the 0 and 1. In classical set theory, either a particular object is a member of set or not. If it is a member, the degree of membership is 1. If it is not a member, the degree of membership is 0. But the fuzzy set theory provides you the opportunity in which you can say that a particular object is a member of set with certain things in between 0 and 1. So that is how the fuzzy system is very, very important, and Jaydev has a very great contribution in this domain. I'll give you a little bit larger picture how fuzzy systems works. So in general, you will go in these kind of topics will be discussed in third unit in detail, but to make you subject more interesting and more insightful so that we can connect with you the subject, I am discussing here the fuzzy system. Broadly, the fuzzy system have 4 components. Rule-based system. When we say rule-based system is nothing but you write a lot of if-else conditions when you write a program in C. So same format rules are there. If condition A satisfied, this will happen. If condition A and B satisfied, this will happen. This kind of rule are called fuzzy rule system. Then fuzzification model. See, when this kind of statements are there, I may go on walk with my friend or may not be. So mathematically we have to be, there are ways and means to write these kind of sentences in the set form and do the fuzzification. So next thing is fuzzification models. Inference engine. Inference engine is what? Let's say now you provide the input, lot of rules are there. And the task of inference engine is that on the basis of input, it will check the fuzzy rule based system on which kind of a particular set of rules this kind of input will match or somewhat match, probability of matching. Accordingly, it will not give you the exact solution. It will infer the solution. It will infer the output condition. When inference is taken, always inference may be imprecise also or a little bit more closer to correct solution. That is why we are using the word approximation. Then finally defuzzification. And ultimately you have to get an answer. So you cannot say that I may or may not go on the walk is a correct answer. So you have to do the fuzzification. So this is how any fuzzy system is developed. So the target of or goal or the learning outcome of this system is to understand about the fuzzy set theory and how to design a fuzzy system and how to solve the different, probably at the larger, you can say that how to design a fuzzy controller also if you are a EC guy. But the IT and CSE guys also have to be fair knowledge about the fuzzy controller, because nowadays is a very popular thing in day-to-day life. All right, guys. I hope the point is clear about the fuzzy system and fuzzy set theory. Next, very important, very interesting is evolutionary algorithm. I think most of you have gone through the biology, as we were discussing in the previous slide also in 10th class, and you were about the genetic algorithms, genetics. I think all in day-to-day life also, every day we are reading in different newspapers, or we are following different news articles or print media or electronic media, that the agriculture scientists are doing a lot of genetics things on the plants, and they are developing new species or new crops for the paddy or wheat or whatever. So what they are doing it? They are trying to alter the genes, and for the generations. For first iteration they do some altercation. The next they find out the result is not good or bad or whatever. Then they modify the genes, and that is how they try to find out the new crops or the better crops. Now imagine that if we can write these kind of programs, this approach can be applied in programming, and we can develop some algorithms to write these kind of programs. Then these kind of algorithms will be called evolutionary algorithms. Evolutionary computation is inspired by the biological genetics found in living nature. Simple, powerful, domain-free, and probabilistic in approach to general problem-solving techniques. Evolutionary algorithm models include phenomena of natural selection. I hope all of you have studied and have a fair knowledge about the Charles Darwin's theory, survival of fittest. So this all evolutionary algorithm is based on the survival of fittest methodology. We will discuss in detail when we will discussing the 5th unit of this syllabus. But 3 kind of a major operators are used: crossover, mutation, and election, you can say, and survival of fittest. So there is a fight going on in the genes, and the fittest gene is survived and passed to the next generation. And this iteration is going on. Biologically, you understand. Now what we will learn in this subject, in soft computing, in the last unit, how to write a mathematical model to develop the genetic algorithms. So that is our learning outcome of the 5th unit. You can have a little bit perception from this figure also. See the initialization, a population is there. The random size is there. A lot of genes are there, and on the basis of their attributes, you find out few genes and select few genes, and apply operators, mutate and other kind of things, like with the I was discussing with the agriculture scientists are doing. And finally you find that until gene is not very strong to develop some new thing, this fighting and this process is going on, and you develop, this is how we develop the evolutionary algorithms or genetic algorithms. I hope I make the introductory part of genetic algorithms clear to you, and it makes sense to study this subject. All right, guys? Okay. Then finally, artificial neural network. So there are 3 words: artificial, neural, and network. I think you have a fair little bit idea about the neurons in human brains. The billions of neurons are there. In next video lecture, we'll discuss about how the neurons look like, what is the attributes or what is the functionality of a neuron, and how different neurons talk to each other. When we say talk to each other, means how they make a network. So guys, what we are going to learn in this topic, artificial neural network, we are going to simulate a human brain's neuron. Human brain neurons means what? Neuron is a basic unit which is supposed to be in human brain to calculate something or to process something, or like elementary processing unit, we can say that. So in this kind of a topic, we will learn the mathematical model of neuron. We will try to establish analogy between the mathematical model of neuron and biological analogy of the neuron. Then ultimately, we will see the different combination of the neurons and different topologies in which we can put on the neuron. When I say different topologies, when we put the neurons in different topologies, in different layers, so that topology or that network is called artificial neural network. In a nutshell, we are trying to a mathematical model, we are trying to simulate a human behavior to perform a particular task. I am not saying that it will completely behave like a neural network, human brain, but we can design a neural network on the basis of our experience or of concept of mathematics and concept of biology. We can put neurons in different topologies to perform different tasks. So let us understand the neural network also. This is very, very interesting topic, and nowadays is very trending also. Machine learning, deep neural network, AI, a lot of research is going on, and a lot of scientists, researchers are trying to make the system intelligent. And when we say system intelligent, we have to model the human intelligence, human brain, and it can be done with the help of artificial neural network. We have to apply the concept of fuzzy also. So this is very, very interesting topic. And nowadays, we will see the next video lecture, the application of neural network, fuzzy system, and soft computing also. You see the almost all areas of life, day-to-day life, there is a application of soft computing. We have discussed the example of washing machine. You can check on, you can Google that the application of soft computing or neural network on the grid computing or power distribution system, to develop the power distribution system. The entire power distribution system can be automated or intelligently can be designed by using the concept of artificial neural network, right? So, my dear students, neural network is a network of artificial neuron inspired by the biological network of neuron that uses mathematical models as information processing unit to discover patterns in data which is too complex to notice by human, right? So sometimes we have to, it's a large number of data is there, we have to find out a new pattern then we can use neural network. So this is, let me summarize again about the lecture. What we have learned in this lecture, we try to do the context setting of the subject, which is very, very extremely critical, very, very important. So that as a teacher, as we were discussing about the initial times of this lecture, as a student, as a teacher, we have to correlate our day-to-day life functionalities with the subject. Then it becomes very easy to understand the subject, and teacher also enjoy to teach the subject. So let me summarize the lecture, guys, for you. We understand the meaning of soft computing, hard computing, difference between soft computing and hard computing, and what are the different branches of soft computing. And there are three main branches of soft computing are there. One, artificial neural network, fuzzy system, and third one is evolutionary algorithms or computing. So as I was discussing, first 2 units belongs to your artificial neural network, and unit 3 and 4 belongs to fuzzy system, and the 5th unit belongs to evolutionary algorithms. So the learning outcome of this subject as a teacher, which I can expect from you is what? My clear thing is that you understand the fundamental of soft computing, understand the fundamental of neural networks, try to develop a different neural network models mathematically, independently, and handle the fuzzy systems, fuzzy inference systems, to design a new fuzzy systems, and to write a evolutionary algorithms also. And finally, I expect that you, as a student, after studying this subject, you are able to write your own fuzzy systems, you're able to design your own neural networks or evolutionary algorithms which can solve some day-to-day life problems. So guys, this was about today's lecture. You may have certain questions, note it down those questions. I'll take those questions in the regular class or in the next video lectures.